Alright, so now we are working on Chapter 6. This is the test review part 2, and we're going to be working numbers 5 through 8. Now 5 through 8, well, specifically 5, 6, and 7, are all about choosing the method that you want to use. Now what that does, of course, mean is that the method that I use might not be the one that you would like to use. So, of course, it doesn't actually matter what method you use as long as you arrive at the correct answer. Now, problems 1 through 4, of course, it does matter which method you use, but of course, getting points is better than not getting any points at all. So if you're no good at substitution and you don't remember how to do it, go ahead and use elimination if you'd like. Just understand that you can't get full credit unless you follow the directions. So make sure that we're clear on that. So for this particular problem, I am going to work on solving this one by substitution. Even though substitution is my least favorite method, I feel like this one is ready for substitution. I've already got a y value mostly by itself. And so I'm going to take and divide this by 3 here, and by 3 here, and by 3 here. Now the problem with this, if you check this out, this might make me rethink the way that I'm going to solve this. Dividing by 3 will work here. Of course, we'll get y equal to, sorry, not y equal to 1, but we'll get a 1y. Here I'm going to get a 4x, but if I check this out back here, I'm going to get a 10/3. Well, that's just not very much fun. And so now I'm going to have to deal with fractions. So I think I'm going to rethink what I'm going to do. Rather than dividing by 3, maybe I should set this up for elimination. So if I'm going to do elimination, I need to get the x value, that is the 12x, back on the other same side as the y. So let's get rid of the work that I've done so far, and let's see if we can't make this problem work in my favor. So you can kind of see that just because you choose a method doesn't mean you have to stick with it. If it gives you fractions, then chances are that there is a method that is going to be easier. Now, having said that, you don't have to have fractions will work. It's not like it's not going to give you the correct answer. It just is that I know that many of you do not enjoy working with fractions. So I'll be taking this minus 12x. Actually, let's go ahead and change color here. Let's get back my black pen. So I'm going to be taking this 12x and subtracting it to the other side. And when I do that, I'm going to copy this new problem down kind of over here off to the side. Let's shrink this back down a little bit. Move this over a smidgen. So when I rewrite my new problem, I will have negative 12x, a positive 3y equal to the 10 that's left over there. Now, of course, here we have 4x, and then minus y, and then equals 3. And so I am going to take the bottom equation to get a common multiple. I'm going to get rid of the x's, by the way. So I'm looking between the 4 and the 12, and if I take that 4 and multiply it by 3, that should work out so that everything will cancel out. So if we then multiply through, of course the top one remains the same. The bottom one, however, is going to turn into 12x minus 3y equal to 9. And the top one, negative 12x plus 3y equal to 10. And when we go about combining these, negative 12x plus 12x, 0, they cancel out. Then we have 3y minus 3y, they cancel out as well. Well, that leaves me with 0, and then 10 and 9 is 19. But 0 is not equal to 19, so that is a false statement, which means that my answer is no solution. All right, so let's check out number 6 here, using any method to solve this time. This one is, I believe, pretty much ready to set up for elimination. We do need to do a little bit of work. I'm going to choose to eliminate the x values, and so I'm going to need to take that top equation, and I'm going to need to multiply that by a negative 2. Right now my problem is, of course, that both of these are negative, and I'm going to need one of them to become positive. So when I choose to multiply the top equation, we're going to need a negative out here. Between the 2 and the 4, I'm going to make this 2 become a 4 by multiplying by 2. And so we'll multiply this entire equation by negative 2. When I do so, I wind up with a positive 4x, a positive 10y, and a positive 28. The bottom equation remains untouched and unchanged, negative 4x minus 2y equal to 4. My x's will cancel out. I'll wind up with 8y, and 28 plus 4 is 32. Dividing by 8 will get me y equal to 4. From here, I am going to take that 4 and I'm going to plug it into, I kind of like maybe plugging it into the bottom equation. And so we're going to have this negative 4x minus 2 times 4, since y is equal to 4, and that will be equal to 4. Now, 2 times 4 is of course 8, so we have negative 4x minus 8 equal to 4. Add 8, and negative 4x is equal to 12. Dividing by negative 4 will get me an x value of negative 3. Putting the two together to make my final answer, negative 3, positive 4, put it in parentheses, and that is my answer. Let's hop down here to number 7. Now, number 7 is all kinds of not okay. I could divide by 6, but get that x by itself, but that's going to give me some fractions. What I need to do is make sure that my variables are aligned. So to do that, I think that I am going to take this 7y that's right here, and I'm going to bring that over to this side. This side has my y and then the x here, and so I'm just going to take this y and move it over here. So, to that end, I will be subtracting 7y from both sides, and that will give me the new equation of negative 21 equal to a negative 7y minus 6x. The top one, of course, has yet to be touched, and so I have negative 26 equals negative 3y, and then minus 5x. Now, of course, my choices are to get rid of the y's or to get rid of the x's. I think I would like to play with the kind of like the x's, and so we'll multiply the top equation by 6, and we'll be multiplying this bottom equation by 5. Now, small problem, they're both negative here, and so I'm going to need one of them to become positive. I think that I will multiply the bottom one by a negative 5. So once we get that started, we wind up with, let's see, negative 5 and negative 21 is going to give me a positive 105 equal to a positive 35y and a positive 30x. Then multiplying by 6, we're going to wind up with a negative, and let's see, that's going to give me 6 times 20 is 120. 6 times 6 is 36. 120 plus 36 is 156. So we have a negative 156, and that will be equal to a negative 18y and a negative 30x. Combining these two equations together, my x's will drop out, and 18 minus 35, or sorry, a negative 18 and a positive 35 is going to get me 17, and so we wind up with a 17y equal to, and then of course we're taking 156 and the 105, the negative 156 to get a negative 51. Dividing both sides by 17 will give me a negative 3 equal to y. That's a good chance to use your calculator there. And so then I will take that negative 3. I'm going to plug that into, let's see, solving for x. I kind of like the idea of plugging that into the bottom one here. And so I've got this 7, and the y we said was negative 3. So we have 7 times negative 3. and then minus 21 is going to be equal to a negative 6x. And so what I did was I used this bottom equation right here to plug in the y value. So if I continue, this is negative 21 minus 21 equals negative 6x. That's negative 42 equal to negative 6x. Dividing by negative 6 gets me an x value of 7, which means when I go to write my final answer that I have a 7 and negative 3 in parentheses. All right, last problem on this side is an old review problem. We like to throw these on here because anything that we have learned this year is fair game for your final exam. So we find it handy to kind of throw some of these on here to make sure that you remember how this works. So it just says write the equation. So there are 3 different equations that we could write. I will show you all of them. But of course they are going to have to start first and foremost by finding the slope. So I'm going to have to use the slope formula. And y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which is going to give me negative 3 minus 2 all over 1 minus 0. Well, that gets me a negative 5 over 1, which is, of course, just negative 5. I'm going to pick one of my 2 ordered pairs. Remember that ordered pairs are made up of an x value and a y value. And my first answer could be in the form of point slope form. Y minus y sub 1 equals m times the quantity x minus x sub 1. M we have, that's the slope we just found. And I'm going to choose the ordered pair 0 and 2. And so we'd have y minus 2 equals negative 5 times x minus 0. And this, by the way, is an acceptable answer. That is an equation that I would accept. Now, most of you will probably wind up continuing on to solve this for y, so that we have slope-intercept form, so adding 2 to both sides will give me my slope-intercept form, which remember is y equals mx plus b, and it is y equal to negative 5x plus 2. And so that is also an acceptable answer. There is yet a third option if you so desire. I don't imagine that most of you will want to go this far, but it is here if you are interested. Standard form would add the 5x to both sides, leaving you with 5x plus y equal to positive 2. And remember that your standard form, of course, is ax plus by equal to c, which would mean that this fits now, 5x plus y equal to 2, and that would be an acceptable third form. I would imagine, however, that most of you will probably spend your time working on getting into either this form, the point slope form, or the slope intercept. Sorry, this is point slope. This one is slope intercept. I imagine your answer will be one of those 2. All right, so next I will be working on the second side of this. So the second side is just going to be work. Won't be a whole lot in the way of commentary. Hope the video was helpful, and I look forward to seeing you on Thursday. Bye.